Hello everyone and welcome back to episode number 5 of Ben's Learning Lounge. It's great to have you back. So today we're going to be talking about astronomy and astrophysics. Yes, you might have heard in the news recently about the recent astronauts being sent to the ISS, so I thought there's no better time to talk about the topic. We're going to be talking about a lot of interesting fields today, such as is there a heat limit of the universe? Did we just potentially miss a mass extinction event? Is a nearby star ready to explode into an incredible supernova that's seen by Earth? Does alien life exist? And my favourite, who is Sharon? Today we're going to be talking to Niam about that. He's just recently completed his degree in astrophysics and he's done a lot of really incredible work, such as programming a simulation of the solar system. He looks at the severity of solar storms and how they affect Earth. He's looked for the earliest stars at the edges of our galaxy, and for his masters he's been looking at particles shot out by exploding stars and why they aren't spread evenly across the sky. So a lot of really amazing stuff coming up. Just a quick reminder too that this podcast is a fundraiser for Mind. If you'd like to give to those, please go to justgiving.com/fundraising/Ben's Learning Lounge. One more time, that's justgiving.com/fundraising/Ben's Learning Lounge. Hope you sit back and enjoy the show. All right, hello there, Niam. Welcome to the podcast.
Hi.
How are you doing?
I'm doing good, yeah. Cooped up as always in lockdown. As always, for the past how many weeks in lockdown.
Yeah.
But yeah, just hanging on.
Well, all right. So the first thing I definitely want to start this podcast off with a big question that I think can get confused sometimes with people, and I am guilty of getting confused with it too.
Okay.
You work a lot in astrophysics.
Mm-hmm, yeah.
What is the difference between astronomy, astrophysics, and dare I say, astrology?
Oh. Okay. So I've had enough people go to me and talk about astrology, and I'm like, no, it's not the same thing. But okay, so astronomy is a lot of observation. So it's going out there with a telescope, looking at stars. It's often like, I don't know, I kind of attribute astronomy to a lot of angles. So like the coordinates of where you're looking at, even like tracking objects and that kind of stuff. And I guess a more hands-on approach, really. When we talk about astrophysics, we're talking about, it's really wide. The field of astrophysics is very wide. You have like theoretical stuff, so you can take the things you know about matter and how it acts and apply it to, say, the core of a star, and you don't have to actually look at it or anything. You can just do a purely theoretical view of it, with mathematics. Like astronomy, a lot of the work is the act of seeing, like using a telescope and kind of the fine-grained stuff around that. Whereas like astrophysics tends to be just using a telescope and using what you see with it to do stuff.
All right, I think I get. So in short, would you say, and correct me if I'm wrong, astronomy is observation, astrophysics can be more theoretical.
More theoretical, but it's also, in its more observational like parts, it's using what you see. Whereas astronomy is just seeing for the sake of it, kind of, mostly.
I see. And astrology?
And then, of course, astrology is, astrology, I'm not, I'm not a leading figure on astrology, or astronomy, or astrophysics. But yeah, astrology, I think is more like when we born, what's your rising and whatever sign, and
right. That's all. That's all. Your Cancers, your Tauruses.
Your Libra. That's what I am.
You shouldn't have said that.
Someone's gonna listen to this and like, I know. Yeah, someone's gonna listen to this and make like a whole plan of how my life's gonna go now.
Someone's going to make a plan of how this podcast is going to be based on the fact you're a Libra.
He's a Libra, though.
And also the last thing, which I'm not going to lie, I also used to confuse, a meteorologist, that's someone who does the news about weather, right? Is that correct?
Well, it's not the news, but it is like weather.
Meteorologist.
So meteorology is a study of weather, yeah.
Okay, so you are in more ways than an astrophysicist.
Well, we can ask me that in about a month, and I guess I'll know.
Yeah, of course, you've just done your masters, haven't you?
Yeah, just handed in my report. So
that's brilliant. What was your topic on?
So it's looking at cosmic rays. They are these high energy particles, so they get thrown out of exploding stars and supernovae. That's what we think, anyway. And essentially, they go throughout the galaxy, and they get bent. Like their paths get bent and curved throughout the magnetic field that's in the galaxy. Because of that, like bending and curving, when we measure them here, when they hit the Earth and they basically scatter and become loads of other particles, we should see them as coming from everywhere. Like every area of the sky, there should be like a fairly equal amount. But that's not the case. So there are like hot spots and there are like cold spots of how many are coming at us
Ah,
and we don't know why. So I was studying data from a detector in America that's like been shut down in 2016, but it ran for 13 years. So I used some data from there to get the like arrival location. So I basically built a sky map of where these things were coming from and in what amounts.
so you're actually working on real, well, I don't want to say real science, but you're working on like very recent stuff. You're looking at questions that are even yet to be solved.
Oh yeah, definitely. Like this kind of thing about it's called like cosmic ray anisotropy, which is so isotropy is where you look around and everything you see looks the same. It's like looking at a blue sky that's perfectly blue. It's isotropically blue. So I'm looking at cosmic ray anisotropy, and that kind of field started like really vaguely in the 60s, but no one like the detectors there weren't good enough. And now, like from the 90s onwards, that's when we really have this kind of like in-depth look at what like of this field. And even then, like I guess say 30 years, that's still like really really short term in science.
Yeah, of course. Well, is cosmic rays also linked to? I think I've heard the term before used, like when the sun has a little explosion. Is that also cosmic rays, like the radiation that comes off that?
Oh yeah, so when the sun like has an explosion, it's called usually it's called a coronal mass ejection. So that's when like part of the atmosphere just flies off, just explodes. Those particles actually consist of the lower end of the energy spectrum. So if you look at lower energy cosmic rays, they are what is thrown off of the sun.
I see. So it's so cosmic rays. Cosmic just means anything which comes from the sky, right?
Yeah. It's from the wider universe. So it can be in our solar system, it can be outside of it, it can be from other galaxies as well.
Wow. The thing that I still find incredible is that we have equipment that can pick up the fact that it's come from, how many thousands and thousands of light years away.
Oh, definitely, yeah. It's actually crazy because we even have like spacecraft that can do this. We have like the detector I was using was underground. It was 700 meters down a mine shaft, and like that kind of stuff.
Gee, what? It was underground?
Yeah, underground detectors. They're really good for what like this kind of research because the rock in between the surface and the detector like filters out all the slow energy stuff. So that's why with our detector we get.
Oh, so it's like a purifier.
Yeah,
almost.
kind of like a sieve. It takes out all these like low energy ones that the sun throws out, and it only leaves us with the ones that in a certain energy range.
Wow, that's incredible. Yeah, it's things that I just find incredible to believe about how far we've come in space technology. I know that there's been sort of like elements recently where I've heard there's like less funding, for example, in things like NASA. Yet it still amazes me just how far we've come in that field when we're still yet to know what's at the very bottom of our own ocean.
Yeah, it's interesting seeing what can be done with as little money as well, because there's still like plans for like even given like I guess the relative reduction in NASA's funding, they still have like plans to go back to the moon. I'm not sure how coronavirus will impact that, but I guess we'll find out.
Bring it on to sort of coronavirus, and I was actually wanted to ask, well, firstly, sort of two-part question. For people like you, how do you manage to keep yourself busy in that world during quarantine times? And also, how could other people who potentially have an interest in astronomy or astrophysics who've never really explored it before, is there a way for them to sort of get into it while everyone's still in lockdown?
I mean, definitely, yeah. So it's I guess the easiest way to get into astronomy and observing is just like go into your garden, lay down a blanket, lie down and watch the stars. And like stargazing is such like an easy thing to do. And even if you I don't know, if you want to see what you can see and kind of record it, you can have like a little notebook and you can like draw little points and try and connect them and try and see what constellations you can see. And that's a really good introduction to what astronomy is. And even like further on from there, you can do things like I don't know, go on Amazon, buy a cheap telescope, and like it doesn't have to be anything fancy, but you can see a lot of stuff. Binoculars as well. If you've had binoculars, if you're maybe a dad likes to do some bird watching or nature stuff, those can those can be used to observe stars as well, or the moon.
So you don't just have to use binoculars to look at birds. You can actually use them to look at things thousands and thousands of light years away.
You get a better look as well, and you can look at the planets through them as well, depending on the binoculars, of course. But yeah.
Yeah, I mean, that's one thing which is definitely interests me in the field. I've heard, for example, that sort of in next week or so, that like Mars and Jupiter, I think, are going to align a certain way above the moon. It's going to look like a smiley face. And I've seen zoom-ins before of people with these like incredible telescopes, and they zoom in, and you're like, God, like, you know, you look at it from here, and Mars and Jupiter, they do kind of look like stars, I guess, because the way the light hits them. And then you see the zoom in, and really, they're just there. You know, it's incredible to look at that you can actually see Jupiter with a telescope from your back
It's
garden.
absolutely incredible. Like, I've seen pictures from my friends as well with like pretty good telescopes, and they've done things like image the moon, so that the four main moons of Jupiter, the Galilean moons, they've imaged them, which is like ridiculous, because like you think about how small they are compared to Jupiter, and you can get stuff like Saturn's ring systems from Earth as well, which, like, I don't know, it's kind of amazing, give you like a whole new perspective on like what's far away and what's big yet far away, and what's going on just next door, kind of.
Yes. Yeah. And also, I mean, another thing is what far away means, but that's something I'm going to come to soon. The next point I also wanted to bring up was you talk about like Jupiter and its moons. There's a bit of a debate, isn't there, amongst the scientific community, if I'm right, about what is actually classed as a moon. I've heard before that we have one moon. I've heard before that we have 10. I've heard before that we've got thousands that include little things. What's a moon, Niam? Tell me what a moon is.
Well, a moon is like a natural satellite, so something that is made through like the evolution of the solar system. So stuff like impacts with other planets, like say billions of years ago, and when these things are ejected from us, so like we get hit by a big rock, and a different rock comes off and it sticks around with us and begins to orbit us. That's when we have our own moon. Technically, we have tons of satellites, which include man-made ones that we've made, but there's only one like moon of ours.
The lunar moon.
Or was it? I think it was Luna that the Romans called it. I think. Yeah, it's hard because there are a bunch of like, Roman.
Nice.
I think Roman names are what's like often used for stuff in our solar system. Also.
Oh yeah, it is. You got like Mars.
Yeah.
There's the there must be other Venus.
Yeah,
they are, aren't they? They're all sort of named after.
Yeah, Jupiter is as well.
Roman
Juno
gods.
is Juno is the name of one of NASA's probes that went to Jupiter, and Juno is Jupiter's wife. It's kind of his wife checking up on him.
Wow, that's brilliant. That's great.
Also, guess what classifies a moon is often has it cleared out a bit of the area around it. I believe that's it. I know that's definitely a condition for a planet, so that's why Pluto isn't a planet anymore, because it didn't clear out. Well,
what do you mean by
Pluto
that?
If you zoom to Pluto, and we have done with like New Horizons now, we've actually got data from that. Pluto has a very close like brother called Charon, and they're actually so close that they kind of share an orbit. So when we have like these two massive bodies near each other that they orbit around, so let's say for example the moon around us, the center, if we draw like a circle of where the moon travels around the Earth, the center of the circle is inside the Earth. But when we talk about Charon and Pluto, that center is actually outside of Pluto. So
so it's like they're both kind of circling around a point in between them.
A visible point that's in between them, yeah. And
I see.
There's tons of other like little objects as well that are kind of blurring the line between what's a moon and what's a planet. So because Pluto couldn't clear out its like the path that Pluto orbits around the sun, it couldn't clear it out, and it's got these massive like kind of Pluto-sized objects around it as well. It isn't called a planet anymore.
That's amazing. So if we did call Pluto a planet, basically you're saying we'd have to class a lot of other things around that area as a planet.
Yeah, like Pluto's really close to a region called the Kuiper Belt, so it's where there's tons of these icy kind of cometary, kind of not bodies, and they also haven't like cleared out of space around them either. So we'd have to call a lot of those things planets as well.
And also to think that now I know the fact that there is a moon-like body that's near Pluto called Charon. I mean, who would have thought? Yeah. There's a Charon out there. You know, you got the Jupiters, the Marses, the moons, and you've got Charon.
I have to say, Charon is in CHARON, not Sharon as in.
Oh.
I think in Eastern character Sharon. No, not her.
Oh no! Well, now you've ruined the magic for me. Something else I also was interested in, like about these similar to like moons and stuff, but also I hear a lot in that I'm gonna be honest with you, Niam. I do occasionally look at the Sun newspaper. I know.
Okay. I was worried then. I was like,
yeah. Well, you should be.
Actually, I'm not sure if the Sun is worse than the Sun or not. No.
No, I don't know. I think that's really bottom tier with the facts that it has. But it always talks about being concerned about a comet coming towards us or a meteor, or I don't know the difference between those. But should we actually be... Is there any reason for us actually to be worried in the future about a comet or meteor hitting us? Like, has it happened before? I mean, obviously it's happened before, I think, at least theory-wise with the dinosaurs, but has there been other cases where we've had close shaves, and should we be worried about the future?
We have, like, close-ish shaves, but nothing, like, that's to worry about. I think a lot of the stuff that we do with observation stuff is that we have a bunch of, like, a series of telescopes and satellites that observe objects near Earth. So these are called NEOs or NEOs, near Earth objects, and but we track them. So one thing that we do is kind of related to the simulation. It's when you know the positions of all these objects, you can kind of guess their masses. You can usually predict how they're going to travel or how they're going to move, because we know how gravity works. At least like on these scales, not like talking about black holes or quantum gravity. I don't know if that's the thing. But we know we can understand how gravity works. We can understand where these things are, how fast they're moving, and how much they kind of weigh. So we can figure out where they're going to go, mostly. Of course, there's some uncertainty, and that leaves a worry, because, of course, if there's an uncertainty there, like, say, by a few million meters, it could be that the asteroid hits you or goes past you and you're not sure. Yeah, so in terms of, like, how often asteroid impacts happen, we are a bit overdue an extinction-level asteroid hit, so that's slightly worrying, but I guess it's not a thing to, like... There's no point in, like...
Hang on, Niam. You can't just drop that bombshell in the podcast that actually we're overdue in a mass extinction and just kind of gloss over it.
That's talking like pure statistics, so it's not like it's going to be... There's no idea knowing how big a hassle it's going to be. Maybe stuff like the asteroid impact in 1914, I think, in Siberia. Maybe that was one, but it didn't really... It messed up...
Wait, there was a... Hang on. I got more questions than answers right now. There was a big meteor that hit Siberia in 1914.
Yeah, it's called the Tunguska Impact. So no one saw it because it was in remote Siberia, and it was 1914, so no one could text out or tweet that it had happened. But the people had heard this massive explosion, came to see it, and I think for about a few hundred meters, every single tree was pointing away from this central impact point.
Wow. So it was just a asteroid that just hit the Earth, and a big one, I'm guessing.
Well, in the grand scheme of things, not very big, because if it was bigger, then we would have a massive impact crater. We'd have all the lovely apocalyptic stuff you've probably seen on movies and stuff like that. But no, it wasn't anything too big. It just it was an impact though, and maybe extinction level events aren't like massive rocks or something. Maybe we're extrapolating a bit. I'm not sure. I haven't looked at all theories, but yeah.
I suppose that there's also a chance too that these things, could happen anytime, within the range of 1 million years from now. Like there's a sort of big area where it could happen, so it won't necessarily be tomorrow as much as it's likely to happen in a couple of million years' time, right?
Yeah, definitely. And like the whole thing is like, there's no point fretting about it, because it's just it's a thing that we have the ability to look at them and see it coming, at least do something about it, possibly. But there's no point fretting about it, because in the end it's like one of those things that's happening around us, and we just have to kind of not let it stop us in our tracks, I guess. You have to think about it.
Well, also when it comes to things to look out for, I also heard something about supernovas are a thing that happen right in space. Is there a possibility for us to ever... Because there's so many stars around us, it would surprise me for there not to be some kind of time where one of them would just explode. We can, have a little peek.
Well, that's like, was it recently, I guess the astronomy, astrophysics, kind of everyone was really, really getting riled up for Betelgeuse. So Betelgeuse is a massive red giant star.
It's a good film.
Also, maybe a better star, I'm not sure. It's around about 200 light years away, and it is in the kind of mass, so it has the mass, it's in that range of masses where it's likely to blow up. It's almost certain to blow up at some time, and like recently there's this kind of like funky lowering of light. So we measured the light coming off of it, and over time it was slowly dipping, and because it's not usual, everyone was like, "Oh, it's gonna blow up! Oh, it's gonna blow up!" And then suddenly it resurrected itself, and its light went back up. So no explosion here.
But in the span of the universe, it's not a long time
No,
till the
not at
thing
all, not at
blows.
all. But the thing is that if it does explode, we will have an amazing viewpoint from Earth. It's like we've seen very distant supernovae in other galaxies. So we've actually, what was it? We saw one, I think, in Andromeda, that was so bright that it actually like was brighter than the rest of the galaxy for a little bit.
Wow,
Um,
Jesus, that's great. The amount of light these things
no,
give
it's
off.
incredible. It's so like these put out so much energy that even was it the Crab Nebula that was from an explosion that was seen in the 1800s, 1200s, the 1800s. I think it was the 1200s actually. But it was so bright that people like noted it down because it was like a huge happening in the celestial sky.
So we could actually have something else just like that, but
Mm.
maybe even brighter, right? Because you said Betelgeuse is a big boy. It's a
Yeah,
big
big
star.
star, and it's quite close by as well, so that really increases the chance of us seeing a lot. And every scientist will be willing to every detector they have to pick up whatever that throws out.
All right, exciting stuff. So bear that in mind, people, in case you, just in case you might be the lucky ones who gets to see it, or your kids or so on. I also wanted to mention, I know that there's sort of an absolute zero temperature, which I was wondering if you could describe, but also, is there a heat limit as well of how hot things can get, as well as how cold things
Okay,
can get?
well, so absolute zero. If you imagine, so basically, the big secret of physics is that everything is vibrating, like everything. Um,
Don't
in
tell anyone.
you can't tell anyone, it's only from me to you guys. So many things of physics can be broken down into kind of oscillations, so like in a spring going up and down. When we look at what atoms do, they're vibrating as well. You kind of think of the two atoms that are together in a molecule, and between them is like kind of the spring. As we go down in temperature, this vibration, this movement, lowers and lowers and lowers and lowers until you get to the point in absolute zero where it's not moving at all. Absolute zero is technically a theoretical temperature. We could never like reach that in the laboratory because we'd need an infinite amount of energy to do it. Believe, or we'd have to move the energy of a system so far away that it would be kind of
Right.
impossible to
So
do.
it's more
Yeah, but
theoretical.
it's stuff that like so in the university I've just done my work at Lancaster. They have one of the world's best low temperature departments. They have these fridges which are really well isolated, so they are suspended above a chasm with air springs. A chasm being like 10 meters, but it's still like it still have like this isolation between with air springs. They have Faraday cages to stop infrared radiation coming in, heating up the samples. They have like a three-step process of cooling down. Can get so cold. Like if we imagine that in I guess Blackwell Tower. I guess people might know that. If you
It's like, if for those who don't know, it's like the Eiffel Tower, but little bit, just a tiny bit
yeah, just
smaller.
a little bit. But if you imagine that the floor of Blackpool Tower, the bottom is absolute zero, and the top is room temperature, and so that's 330 Kelvin around about. I'll mention what Kelvin is. Kelvin is a scale where zero is absolute zero, and any other number just goes up from there. And it's like 1 Kelvin is 1 degree Celsius, which is quite nice. But the temperature that we get in Lancaster is about the width of a human hair off the ground.
So hang on, what does that
So
mean?
if the top of Blackwell Tower was room temperature, the bottom, the floor was it was 0 degrees like Kelvin or absolute zero. The lowest temperature that Lancaster can get is equivalent to the width of a human hair off the floor. So we're almost at absolute zero.
Oh wow, I see. So we are very,
Yeah,
very
incredibly
incredibly
cold.
cold then.
Again, the coldest place in the entire universe. Even space is warmer than this.
Do we ever just dip stuff in there to see what happens?
I think someone, not quite the same temperature, but someone cooled Lego figures. There's a video about that, about Lancaster that did that, yeah. Just interesting. And yeah,
No
it's like a
way.
nice introduction to like low temp, but it's also just like, why did they cool Lego figures? Okay.
That's the coldest Lego. So if anyone wants to see it, you can maybe,
Yeah,
I
YouTube
suppose,
that.
Lancaster Uni.
Yeah,
Yeah,
yeah. On the YouTube page, they've got
coldest Lego in the
the
universe.
coolest Lego figure ever, yeah.
So what about the other side of things? What about the hottest? Because I understand that we can have a limit to how cold things can go because that's when the vibrations stop. But do the vibrations can they just keep getting more and more erratic as the higher the temperature?
Yeah, they can. So when we talk about high temperatures, an important thing is to again think about those molecules and the bonds in between them. If you imagine it's kind of like if you imagine an elastic band doing that. If you put too far on it, it's wobbling too much, it will eventually snap. The way we kind of talk about things that are disconnected like that, we call it plasma. So a plasma is an ionized gas. It acts like a gas, a bit more funky because it can be affected by magnetic fields, so it can flow like a liquid depending on the magnetic field that it's in, and it can cause a magnetic field because it acts like a liquid circuit kind of like you can have these electric currents that go through them, and then they can cause magnetic fields and they can cause movement, and it's really hard stuff to learn about and also to model as well. But in plasmas, the lowest energy plasma is where you separate the electrons, the negative charges, from atoms, and then they're free flowing. But if we get higher and higher energies, we could do stuff like look at the subatomic particles that make up each individual part. So if we talk about an atom, it's got the protons and the neutrons in the middle. Inside those, they're made of quarks. We can get to such once you get to such high temperature, that'll take probably maybe 100 years of accelerated development, accelerated development. We can actually separate the quarks.
Wow! So basically, we can get the heat of something can get so hot that the particles vibrate so much that they basically get ripped apart to the smallest of components.
The smallest possible components, and that's I actually forget the number of how much that is, but that's not even the limit. The limit is a theoretical limit is supposed to be around about, I think, 1 with 60 zeros next to it, and that's in Kelvin.
What? That's
the theoretical limit. We've never reached that.
That's in Kelvin.
Yeah, so this time we can call it Celsius, but it's still absolutely it's beyond hot. It's nothing you can even conceive of, and I can't give you a thing to compare because I haven't even I can't really think about how hot that is in terms of the physics.
No, I doubt anyone has anything in their pocket that could represent that as well. That's mental. So really, we are actually surprisingly close to absolute zero, which I think is something like minus 260.
It's minus 273.13 Kelvin. Sorry, Celsius. There we go. That's 4 years of degree right there.
There you go. You've learned the secret that everything vibrates, and you know what absolute zero is. You can do Niam's job for him at this point.
Yeah.
So that's how cold things could get, but we're actually much closer to the potential hottest possible number that we can manage within the universe is incredible.
It's so far away from us that I don't think it's physically possible to get to that theoretical max because it's just too hot and so much energy has to be concentrated in such a small space. But yeah, so we're a long way off on the upper edges of temperature.
Wow, well that's kind of cool because it's nice to know too that humans, hopefully if we're still banging about in years to come, that we've still got a goal. I say a goal, but there's always something bigger than us that we can always either appreciate or feel like we're working towards. It's not like we're in a current state where we actually understand everything.
Oh yeah, definitely. I think the thing about science is that you kind of use a key to unlock a door. And then eventually there's more doors behind it, and there's the beginnings of science or philosophy as it would be called back then with the Greeks. So they had a few doors, they opened them, and then from there it's gone out of hand, and there's just too many doors and too many scientists opening them.
Bringing it to my last point, I have to know something from you, Niam, which is very important for me to know. Do you believe in aliens, dude? There's been these things recently. Have you seen the footage? There's footage that was released. If people don't know about when I released this, it would have been about 2 weeks ago, but right now only a few days ago was a footage released from the Ministry of Defense of America, a footage from one from 2004 and two from I think 2015 or around that time. Unknown flying objects which the American government and military cannot discern, and they've released it to the public. This footage, and they all kind of look quite similar to each other. And I wanted to know whether you believed, as someone who has a little bit more knowledge than me in how space works, if you think aliens are real, and also if you think they
Okay, so I believe aliens are real, but But I think that space is too big and the distance is too large for them to see us or come visit us, because even to cross our galaxy, or like the end to end of our galaxy, it will take about 110,000 years for a light signal to travel, and that's the fastest thing that can travel we know of. It makes me feel that you think about the distances, that's just one galaxy, and you think about the time. So how long has our galaxy been here? 11 billion years. Our planet 4 billion years. Us? We're nothing on that. One thing that is online, I think, and you probably find this on a lot of websites and videos or whatever, is a clock. So a clock where zero, or like the beginning time, is the Big Bang, and then the final time, so 24 hours later, is where we are, like the current time now. And in that entire clock, we're nothing. We're like a second, maybe 2 seconds. But it's because like cosmic time is so large, and the time we've been around and being able to pick up and send signals has been nothing compared to that. So I think right now it's out of the question that we can either do anything about aliens, like see them or have them visit us. And I wouldn't see. I wouldn't see why in the past they would have visited us either. Like, there's no. Maybe they look out, like if aliens flew past us, say they look out for these kind of planets where there's water, there's land, it's kind of this kind of temperature or whatever, but they wouldn't know that anyone's like smart or like is intelligent on that without a signal coming off.
And I agree with that heavily, that perhaps as well that the aliens have existed, and maybe have come over and visited us years ago, but we've been here for such an unbelievably short period of time. Like you said, like probably on the clock of the scale of the universe, we're at like 11:59:59 towards right now, a second away, that the chances of them seeing us as how we are now is so small. And our current understanding of physics seems to be that if they did exist, and if life isn't common, as much as common as we think it is at least, they would have to travel so unbelievably far to get to us that it almost seems impossible for them to know either that we exist, or for them to come and visit, or for us to still be around, or for them to be around at the same time, living in harmony. I mean, I got told before that we're actually, as far as things go, right, quite early on in the universe. Aren't we closer to the start of the universe than the end, when everything turns into black holes?
Yeah. So we're like, again, 13.7 billion years into the universe. That's like nothing really. We've got possibly trillions of years ahead of us. Not us, the universe.
Well, Niam, thank you for helping me out there and understanding a bit more of the world we live in and the world outside. It's been great to have you on.
Yeah, thank you. Thank you very much for having me.
Yeah, and I think we've all learned a little bit about astronomy, astrophysics, and maybe even a little bit about astrology on the way too.
Maybe a little, yeah.
So yeah, I mean, it's great to hear. It's great to know about all these comets and things that have hit us in the past. Your opinion there on UFOs, what you said about Betelgeuse, about the heat limit and things as well. So yeah, I want to thank you for that. Cheers.
Thank you very much.
All the best here, and obviously talk to you again. Soon.
Yeah, thanks very much. Bye.